Yeah, got a lot of buttons on there. How's it going, Legends? It's just me, Mr. Maze, and Miles hanging out here, wanting to say hi to you guys. He's got a little toy he's playing with here. He was telling me, because, he's so verbose, you should tell your students those pro tips you were going to give them at the end of class. We should give them to them as another video. So we're going to do a quick little walkthrough video. Again, I'm mostly just going to say things. Hopefully you're going to go through your old notes and my old video notes to make sure we're clear on everything. But here are the topics, if you missed them in class, that you might want to remember for the upcoming exam. Thing one, you should know the difference between sampling bias and response bias. And Miles can tell you all about that. Right, dude? Remember that sampling bias has to do with the way in which we actually sample people. So before we ask them any questions or surveys or bring them into the room, the way we get them there when there's a biased method in that. So we don't interview enough of the right people, or we don't get to enough of the places to get a representative sample. Things like undercoverage bias are considered forms of sampling bias. On the other hand, we have, of course, response bias. And response bias is when you do actually get the right representative people in the room, and then you ask leading questions, or you ask things that mess with like social desirability bias, like, hey, do you vote? And people don't want to be honest about that because they don't want to get social reprisal. As Miles will tell you, it sucks to get shamed, even at daycare. It's no bueno. Okay. So know the differences between those. Remember how to translate center and spread. Remember that when we change center, we both multiply and divide and add and subtract, if those things are available to do. Versus with spread, so things like interquartile range, and standard deviation, we only multiply and divide. We do not add and subtract. He is enamored with you. I think he can tell you're on the other end of the screen, Legends. So thank you for looking after my boy with me. Remember also z-score equations. There's definitely going to be at least one question where it's just a setup for a z-score equation. Remember, we don't put the percentile in there on the left. We put the z-score for that percentile. And if it says above which 30% sit, we do 1 minus 30%, get 60%, and then turn that into a z-score. Using inv norm, area, 0.6 in this case, whatever the area is as a decimal. And then mean, which of course would just be whatever you want. I'm just kidding. You need a z-score. It's going to be a 0 for the mean. I almost got you there. And a 1 for the standard deviation, if you want the z-score. Otherwise, if you want the data point, you would use the real mean and the real standard deviation. Okay, remember how to translate, and remember that spread is impacted by only multiplying and dividing, but center is impacted, I should say, by multiplying and dividing and adding and subtracting. Remember, we don't infer things from censuses. Like if you do a census, that's where you just like interview every single person. I feel like I'm telling Miles this too. He's learning with us. He's a part of the class. A census is where you interview every single person in the population, and you're going to get some non-response bias, aka some people are just not going to respond. That's normal. You can't eliminate non-response bias, but you can limit it. But remember, with a census, we're not actually inferring anything. Like, we're not able to generalize censuses. Censuses just tell us about a particular area. So people in Finland do this. People in America do that. Those are censuses. We don't infer from censuses. We just know. It's just a fact at that point. Know the 4, sometimes 5 components of an experiment. C, R, R, C, and sometimes B, right? Comparing, control, right? Comparing meaning between your treatment groups, so like this versus that, right? Getting treatment A versus getting treatment B. Or, rather, getting 30 milligrams of treatment A versus getting 50 milligrams of treatment A. Those would be comparisons. Control, the other C, which means we either have a control group if we need a control group, or if we have something where a control group wouldn't make sense, we have like controlling factors. So oftentimes in questions, it'll be like, we don't have a control group, but we only allowed volunteers who are non-smokers between the ages of 18 and 34, for example. So if you had a question where they were like, we're doing an experiment, there is no control, what's the control element? You would say, well, there's no needed control, but, we only invited people who are non-smokers between the ages of blah and blah. And that just means that's our starting point for our volunteers. Okay. Replication, that's where you say this many people were sent into the treatment group, this many were sent to the control group, or this many were sent into each treatment group, or we had a starting sample of 400 people, right? That's replication, the number of people in the samples. Or I should say the number of people that you then put into the experimental groups. And then, of course, the other R everybody's favorite. We've got replication. We need randomization. Randomization allows us to have causality. Without random treatment assignment, we don't have causality anymore. We know our volunteers are volunteers. They're not randomized. So we randomly assign them to either the treatment group or the control group, or if there is no control group, to the treatment group or the other treatment group. Make sure you know those. Make sure you live them and love them. Ask me questions if any part of that doesn't make sense, but know those in detail. Remember that random assignment does two things. One, it allows for causality. And two, it addresses confounding variables. So aside from blocking, where it's very obvious to us that there's like a variable we should block for, random assignment just sits there as a way for us to ensure that we can limit confounding variables. Not eliminate, but limit confounding variables, because we've randomly assigned people to groups, so ostensibly there are no shared qualities between those people, luckily. Make sure you know the difference between an observational study and an experiment. There are a lot of little differences. You know, we change the variables in, we actually impact things in an experiment. We don't do that in an observational study. But the simplest way to tell them apart, and often the way they do it on the AP exam, is you have randomized assignment in experiments, right? We randomly assign groups to treatment or control in an experiment. In an observational study, we don't. We leave everyone together and we just watch them, right? But that's the key differentiator, so know that. Remember and know the difference between blocking and treatments, right? A lot of times people will mix those up. They'll be like, oh, we're blocking based on height. That's also the treatment. We're comparing heights. No. Ask yourself, what's the explanatory variable, also known as the factor, right? What's the thing that we say, the impact of blank on blank? The thing that you are thinking will impact the other thing, that's the explanatory variable. And that has the treatment groups. So, example, the impact of a hug on my son's happiness, right? Giving hugs would be the factor, also known as the explanatory variable. The response variable would be my son's happiness. And I might block based on age, right? So I might see that when Miles is younger, or when I interview younger kids, hugs have a greater impact on their happiness. But maybe when you get older, you don't want to hug your parents as much anymore, which I'm not looking forward to, but that's life. So I block based on age. Now, my blocking is not my treatment group. I'm not looking at treatment groups and going, kids who are young, kids who are medium aged, kids who are older. No. My treatment groups are still kids. Maybe I would have levels for that factor. Giving 2 hugs a day, giving 4 hugs a day, giving 12 hugs or more a day, right? Yeah, or 3. Good job, Miles. Or 4 a day. He loves counting. He's already killing it. That's what I'm talking about. So just make sure you know the difference between when we're blocking for another variable and when there is actually, like, we're looking at the factor, we're looking at the explanatory variable, and we have levels for that. And know those understandings, right? Factors have levels, and then the treatment groups would be kids getting 2 hugs a day, kids getting 4 hugs a day, kids getting 12 plus hugs a day. Okay, so hopefully that made sense. Let me know if any questions arise from that idea, but definitely understand the difference between blocks and treatments. I think people are grasping that, though. Remember, we can only generalize evidence from an experiment to subjects extraordinarily similar to the people in the study. The most accurate way to say that, actually, is we can only generalize our results from an experiment to the people we experimented on. But AP will accept answers sometimes where you're like, we can only generalize to people very similar to the people in the study. And that's the way they sometimes phrase MCQs. So be aware, we cannot generalize volunteer experiments, even with random assignment, which, remember, we need random assignment for it to be an experiment. We can only extrapolate or generalize that causation to people extraordinarily similar to the people in the control and treatment groups, the people that we sampled in our experiment, our volunteers. And truthfully, we can only extrapolate it to those volunteers. From there, we just have to combine studies over time to then be able to reach more people. So just know the phrase subjects similar to those in the experiment. Okay. Remember and know the difference between sample versus population. Your sample is just the people that you have polled to actually either survey or experiment on. And the population is the greater group that you can extrapolate those findings to. So for a sample, right, if we're looking at like a simple random sample, I might take a sample of 25 people, I think I said in one class at a Baroni convention, right? I only interviewed 25 bronies at that convention, but remember, I can't extrapolate or generalize those results to all bronies. I can only generalize those results to bronies at this convention. So I got to 25 of them. There are, let's say, 300 at this convention. I still can only generalize my results in that sample, even though it's not an experiment. I can only generalize it to bronies at that convention. That's how specific we have to be. Hopefully that makes sense. We can't say like all bronies. And then remember, you should know when you need a control and when you don't, right? So like if a key way in which you'll know if you need a control is often it'll be like they're on a particular medication, or they've been using a particular kind of eyeglasses, or they have been wearing a particular kind of pants their whole life, or something crazy like that. And then or like an assisted insert for their shoes. And then a doctor's like, we'd like to try a new insert for your shoes and see if they're better for you. You need a control group there. You need a group that doesn't know that they're getting the same insert again, and then a group that gets the new insert. And you want to see if there's an improvement there. So you might want to make it blind, but you definitely want to make sure that one group is a control group there, because it's important to see the differences in people who think they're getting a new sole but aren't, and then the people who actually do get the new sole. So think about that. Let that sit in your minds as well. I think that's mostly everything, Legends. But those are the big takeaways. Again, go through everything, make sure you understand, and make sure you have a good idea of matched pairs versus blocked units. But I will say, look at all the FRQs we've done so far as well. Go through the other pro tips video and ask questions, study up. You're going to do brilliantly. Please know, I know it's been like a weird week where we have basically 2 Mondays, a Monday on Monday and a Monday on Wednesday. But please know, I'm here for you. I adore teaching you. It is the great honor of my life that I get to spend my time talking to brilliant people like you and helping you understand the great craft of statistics. I believe in you. Do brilliantly on this exam. Miles believes in you. Miles, can you say bye? Say bye, friends. Bye, guys. Bye. We'll see you soon. Study hard.